Hi everyone, my name is Anvita Bansal and we are back with another lecture based on bit manipulation. So this is the last problem from our section of bits, and let me just quickly check if you guys are able to see my screen. I think we are live. So let me just explain you the problem statement as well. Yes, I think we are live. Okay. So moving on, so this is the problem for today, maximum subset XOR. So this problem asks you to return an integer which denotes the maximum XOR subset value in the given array. Okay, so I hope you understand what subset is. A subset need not to be a list of continuous elements in the array. I hope you know what is subset. So we can have any elements, any number of elements of that subset such that we get maximum XOR of those elements. Okay, so let me just take an example 2 4 5. Now I'll explain it to you. So one possible way is obviously what we can do is, since we have an array like this 2 4 and 5 of elements, what are the possible subsets? In subset we can have only two. One subset can only have 4, one subset can only have 5, one subset can have 2 and 4, one subset can have 2 and 5, one subset can have 4 and 5, one subset, obviously that will be the entire set, it can have 2 4 5 as well. Okay, so now what are the possible subsets? We can, first way is we can find out the number of subsets to the power n, and then for each subset we iterate over the elements of that subset and find the XOR of the elements present in it. For example, 2's XOR with 4, what is the answer we are going to get? Then we'll check what is the answer we are going to get when we do XOR of 2 and 5, and then what we do, we compare all the value. Let's say this is A, this is B, this is C. So we compare A, B, C, which is the maximum of those. So that is what we have to return. Okay. So in this brute force approach, what we are doing, we are first going to create the number of subsets and how many subsets we can have, 2 to the power n subsets, and then we are iterating over the elements present in those subsets. So we can do this problem in an optimized way that takes maximum big O of n time complexity. So let's see how we can solve this problem. So you need to have a good understanding of what I'm going to explain. Means you just need to stay focused and you'll see what we can do in this. Let me just take, before we move ahead, let's just see, obviously I'm sure you all know binary representation. So we will be working around bits. I hope you have already got that gist, that we will be working around with bits in order to optimize the solution. Now if I want to work around with bits, or then how do we write 2? 2 is represented as 1. Let's see, let me write it. Okay, so 1 0 is the representation for 2, and I can write 0 here. This is for your 2. Okay, then your 4 can be represented as 1 0 0. Fine. Your 5 is represented as 1 0 1. Okay, fair enough. Now what? Now okay, hi everyone, I can see people here join the class. Fine. So what are we going to do? See, the target here in our problem is to check how at any index we will be iterating over the number of bits that are present in our number. Now for that particular index, I want to know which numbers, which integers have their bits set at that particular position. For example, let's say right now I'm at this position, pose. Okay, so my position, this is index 0, this is index 1, this is index 2. So right now I'll take it IDX only, or let me take it as position. Okay, so let these be my indices 0 1 2, and position represents at which position index I am at right now. So let's say I start from most significant bit. I start from MSB, and in this case, in these three numbers, I can take second index as my most significant bit, right? So let's say I start from this index. My position is pointing in index 2. Now what is my target? My target is to check in which of these integers that are given in the array have set bit at that particular position. Target is to find what? Pardon my writing. Okay, find integers given in the array which have set bit at position, at pause index. Okay, I hope you got the point. So now tell me, looking at this is the index which you want to see, and which of these numbers have 1 present at position 2. So at index 2 you can find that 4 has 1 and 5 has 1. Now tell me one thing, which is the maximum of these two? Clearly 5 is the maximum of these two numbers which have 1 as their set bit at this particular position. Now what I want to do is, see, right now I am checking for index 2, right, position 2, whatever you can say. Now in those I am going and checking, iterating over my array and checking which number among these have set bit as 1 present at that particular position, right? 5. So what I want to do is, since I started for index 0 in the array, right, I will also be keeping a track of which index I am right now at. So I am starting off with this index idx 0. So whichever index I am at, I am checking for that particular position which number has set bit at the index position, right, pause. So I found the maximum element having 1 as their bit at the position 2 is 5. So what I would want to do is, I will swap this maximum element right now is 5 with element at index 2, element at index for which I started, element at idx. Why am I doing so? See, my target is to bring the maximum valued integer in the starting, such that now what will happen is, now what is the state? I'll just show you. Oops, I'm sorry. So the state now is, let me just erase this so that you can understand. Now you found out that 5 is the number with 1 as its set bit among the integers which are having 1 at this position. So I will swap 5 with 2. Now the integer that I'm going to get is, at this position, 0th position, I'll have 5, then 4 as it is, and 2. Now next what? See, now I know that, okay, now what I want to do is, I would want to swap. I have already done the swapping part. Now what I would want is that I want to replace this value, now which is the remaining value. See, now tell me, 4 has 1 at position 2, right? 2 does not have position 1 at position 2, and let's say one more number we had, whatever it is, for example 8, not 8, be it anything, 1 1 0 for example. Okay, so for this number also we have 1 set at this position. So what am I going to do is, just for an example, now since I have swapped the maximum element with element at index 0, okay, now from the remaining elements, the elements which are having 1 as a set bit present at position pause equal to 2, I will swap that element with XOR of that element with the maximum element. So right now the maximum you have gotten with the conditions that you were trying to check. I hope you are well aware of what conditions we are trying to check. Now what I'm going to do, in the remaining elements of this array, which element has 1 at position 2? Obviously we have only 4 with 1 at position 2. 2 does not have it. So I will replace 4 with XOR of 5 and 4. 5 XOR with 4. Okay, so now what will I replace 5 with? 5 XOR with 4 will become 1. It will become 5, 1 and 2. This is the updated value. Instead of 4, I have made it 1. Why? Because 4 had 1 at the position 2. So I swapped it with XOR of 4. Now, why? Intuition behind it. First, let me see. This question has a lot of parts. Understanding in parts. Okay, so you need to focus on each and everything, and this question will be very much clear only and only if you try to attempt it on your own. Even after you have understood the problem from here, you have to attempt it via some dry run on your own. Only then you will be able to understand. Okay, first let me write what is 5? 5 is 101. Okay, what is 4? 4 is 100. Now what is XOR of these two numbers? Wherever we have different bits, we get 1. Wherever we have similar bits, we get 0. So this is the number we are going to get. So this is the binary representation for what? 1. That is why our array will look like this right now. So what was the intuition behind doing all of this stuff? So intuition was, see, wherever which is the higher element, any element which has ones as their most significant bits will always be higher. You getting this? You check the binary representation of 4. Okay, both have 1, then 5 is this. If I compare 2 and 4, 2 has 1 at this position, whereas 4 has 1 at this position. So obviously, since I have 1 at a higher position, right, the most significant bit is 1, that is obviously at this position. So this is one catch to understand that, okay, the element which is greater will have more significant bits set in the higher position than the other one, right? This is one thing. So how am I going to get a XOR of it? If I do 2's XOR with 4, okay, 2's XOR with 4, let's say, and just to help you understand how XOR is going to get affected, let me just show you. Let's take one constant value. For example, I have 4, okay, and I take a smaller value than 4, that is 2, and do their XOR. So 1 0 0 and 0 1 0. What is the XOR value of these? 0 0 same bit 1, 1 0 different bit 0, 1 0 different bit, sorry, same bits will give me 0, different bits will give me 1. This is 1, this is 1 1 0, and when I do 4 XOR with 5, I am getting 1. Obviously in this, I think what I wanted to explain, wait, have a look here. See, so the intuition behind is the numbers in which we are getting set bit at the higher position, okay. I am, first of all, I am checking out which is the maximum of these, and then in the subsequent numbers, the ones which are having 1 as set bit at that particular position, I am replacing that value with the XOR of maximum element and that value, okay. That is the thing. Now this was for position 2. We have done everything for position 2. Now let's move to position 1. Now we are moving at position 1, and subsequently your index will also be increased. Now you have done this thing for index 0. Now I will run a loop for index 1. Right now my index is 1, okay. That means whatever swapping will be happening for index 1. Now what I want to check is inside this loop, I have another loop which checks what all elements. Now the updated elements of my array are 5, 1 and 2. So let me replace it like this. This is 5. Okay. What is your doubt? Okay. So this is 5. Then we have 1 and then we have 2. So let me write like this. This is 1 and this will become 0 0 and 1, okay. So let me write it properly, 5 1 and 2. Now what are the updated values of your array? 1 is 5, which will be represented as 1 0 1, 1 is represented as 0 0 1, and 2 is represented as 0 1 0. Fine, is that okay? Now we are checking for position 1. In position 1, which element has set bit at position 1? Only 2 has 1 as the bit set at this position, okay. Since I found only one element with set bit at this position, what am I going to do? I am going to swap this element with what? I am going to swap this element with the element present at index 1. Why? Because my index was updated to 1. Now when I swap this with index 1, this is how my array is going to look like, 5 2 and 1. Is that right? Okay. Now what? Since you are checking for this position, now for the remaining elements in your array, do you have any element which has set bit at position 1? Set bit at position equal to pos equal to 1. See, your pos has decremented. Earlier it was 2, now your pos is 1. You're checking for 1. The element with set bit at position 1 equal to 1, I have to find the maximum of it. Among these elements, only 2 is one such element which has set bit at position equal to 1. So I swapped this element with the element present at index equal to 1 in your array. So new array becomes this. Now what you have to check, in the remaining elements, any element which is also having bit set at position equal to 1, I am going to replace that element with XOR of, right now your maximum element is 2, right? Your maximum element is 2 and maximum index is also what? It is equal to 1. Index is also max IDX, my max IDX. So we will be keeping track of all these things. We'll see that. That is also one. So do you have any other element with set bit at this position? No. So we will not be replacing any element with the XOR of that element with the maximum element. So you go to the next loop. Now what does your next loop say? In the next loop, what are you going to do? You are going to check for the last element. For the last element also, for the last element, what you are going to check? Your position will also be decremented. Now you are checking for this position, that is position 0, right? Now for position 0, what is the updated array? Now updated array is 5 to 1, right? Let me write it. And this time your index has incremented to 2, right? So you have 2, you have 1, so this will be 0, 1, 0, and 1 is 0, 0, 1. Now tell me at position equal to, this was 2, this was 1, this is 0. At position equal to 0, which element has set bit present at position 0? You have one element is 5 which has set bit, and other element is 1 which has set bit. Now tell me which is the maximum of these elements. Okay, the maximum of these elements is obviously 5. Now what? Now wait. You have two such elements which are having this at position equal to 0, and the maximum of them is 5. But wait, what we want to do, we want to swap this element. We would want to swap the element with element at index equal to, now your IDX has become equal to 2. You started from 0, you came at 1, now you are at index 2, right? Now what? See, whenever you will be checking for set bits, your loop will start from j equal to IDX only, and j will be less than or equal less than this maximum bits, that is n, and j plus plus. Okay, that's how you are going to check. I'll show you the code, then you will understand. See, within this loop, what I want to show you is, see, you have seeing this loop, your index initially starts with 0. Your index is starting with 0. Then there is this loop which iterates over the bits. Okay, in this problem, the maximum bit that I have was at position, you can take this is pos in our example that we have taken. So your pos, the maximum that a compiler, see, maximum bits that a compiler can process is 32 bits. So in terms of position, the most significant bit will be 31st bit, right? That is why we have defined this 32 here and taken your position as 31. Got it? Okay, so position by position you are iterating, and iterating over this each element of this array where your index is starting from 0, correct? Now one by one you are incrementing your index every time after one iteration. Now what I'm saying is, right now see, we are doing IDX plus plus here. Now right now we are at position where index is at last, index is 0, 1, 2, right? So this j starts from IDX equal to 2, that is we are checking for just last element of your array. And in the last element of your array, you are checking, does that element have set bit at position? What is our position? That is determined by I. So right now my I is at index 0. My position is at 0. So for 0, see, for 0 index, okay, for position equal to 0. And I told you I will not take 5 into consideration, I will not take 2 into consideration, I will only take 1 into consideration. The reason is my index is 2, that is I am accounting for the last element of my array. Now this element surely has set bit as 1. I have a set bit at position equal to what? 0. Right, I started for position 2, then I was at 1, now I am at position 0. So it has set bit 1. That clearly means this will be the maximum element, and since I have to swap, I will be swapping with the element at IDX 2. What is the element present at IDX 2? That's 1 only. So 1 when swapped with itself will be 1. Now wait, next thing that I do is, you know that after swapping, this is the swapping part, the next thing that I do is, your maximum index will be this index, that is the element which you have just swapped. So this becomes your maximum index. Now what I check is, I check that the remaining elements starting from index 0 in my array. So out of all these elements except the element which I just swapped. I swapped this element. So check for the remaining elements. Do any of these elements have bit as set at that position? Yes, 5 is one such element which has 1 at the position 0. So what I'm going to do, I am going to replace this element with XOR of 5 and maximum element. So 5 XOR with maximum element right now is 1. So when you do 5 XOR with 1, what are you going to get? 5 is 101, 1 is 001. So when I do XOR, 1 will be 0, 0 will be 0, 1 0 will be 1. So this is 100. 100 represents what? It represents 4, right? So this element will become, this will be replaced with 4, and now this is how your updated array looks like. I hope this is clear to you. Fine. Now your iterations are done. Is there any more iteration left to do? No. Your IDX, if increased, becomes 3. That is index out of bounds for this array, and your position cannot go to any position that is less than 0. So you are done with all the iterations. Finally, when you are out of the bigger for loop, what are you going to do? Now you will realize that all the elements that you are left with, when you do XOR of all these elements, the resultant is the answer. Now let's do the XOR of all these elements. When I do 4's XOR with 2, 4 is 100, 2 is 0, 1 0. What is the XOR? 0 0 is 0, 1 0 is 1, 1 0 is 1. Double 1 0. Now double 1 0 XOR with 1. 1 1 0 XOR with 1. 0 0 1. 0 1 is 1. 1 0 is 1. 1 0 is 1. Triple 1 represents what? It represents nothing but 7. You got it? If there is any doubt, you can ask me. So if you see, so binary representation of 7 is 111. You can verify that. And let's see, this was a test case and this is our resultant. So what did we do in this problem? Now let's have a quick look at our code. As I explained to you, we are starting our iteration from position. I is taken in my test case. I have taken position and here I have represented it with I. Okay. So position, I am starting from 31st bit. That is, here the integers that you have had maximum of 3 bits, right? That is why I started from position equal to 2 in terms of indexing. But what if you have a bigger number? So maximum bit can be 32 bits. So I start from 31st, that is the most significant bit, right? Starting from the most significant bit, you take an index that starts from 0. You keep a track of maximum index and maximum element. Then your J starts from index, right? Right now your index is 0. That is for the 0th index element of your array. Then it will be 1, then it will be 2. Okay. Then what do you check? You will check for your index is 0. Now your J is pointing to 2. From 2 till 5, which elements have 1 at index equal to I? Any element, set of J is what? Array. Okay. So ARR of J, whichever element is having 1 at position equal to I, okay, and I will check the maximum of those. So I will obviously keep track in the maximum element and the maximum index. Then what I check? I will check if the value has been updated. I will swap it with the element at IDX equal to 0. Right now my index was 0, so I swap it with index 0 element. That the thing that we did here. See, I started with 5. My initially my array was 2 4 5, right? So when I found 5 as my maximum element, the maximum element was swapped with the element at index equal to 0. So this is how my array looked like, 5 4 2, right? Now what? After this, you check in the entire array the element which has just been swapped. This is 5, except for this element, which all other elements have 1 as their bit at index equal to the, not index, at I equal to the position at which we started. So whichever will be, it will be replaced with the XOR of that value. Okay, then we got this array and this thing gets repeated. So finally, final answer, when you are done with all the iterations, we return the XOR of all the elements that are present in the final updated array. Right? So that is all about this problem. I know it's not very easy to understand in one go, but I will highly suggest, see, why did I start directly with a test case? Because now the code is right in front of you. You can obviously do it, you can see and code, but what I wanted was that you understand first that what is happening with the elements in each iteration. Now since you are done with this dry run properly, you will be able to map with what I have done with this code. So I hope you understood the problem. Obviously, if you have some issues, you can always revisit the video, but I hope this is clear to you. If you have any doubts, you can ask me. Okay, I'm just checking if you guys have any doubts. I think there are no more doubts. Okay then guys, if you have no doubts, we can wrap it up. Try to attempt the problem. If you don't understand, visit the video and try again. You will be able to do it. Okay, so that is all for today, and the next lecture onwards we will be starting off with the next topic from our SD sheet, which is tags and queues. We are done with bit manipulation. Okay everyone, see you in the next lecture. Bye bye, take care.